Well, it's the Unknown Mechanic back, and this will be Carburetors 101, Episode 3. And we are going to be working on a 2-cycle diaphragm carburetor on a Stihl MS250 chainsaw. And this channel is for shop owners who have technicians that aren't quite up to par and are always needing help and asking 20 questions. And it's also for the technician who wants to raise their level of proficiency and be able to go through a job start to finish and complete it successfully without asking for help. And in addition, the do-it-yourselfer homeowner who may want to tackle this job on your own, or at least see how it's done properly with the right tools, techniques. So this saw belongs to Bubba Butt Crack, and it says dies when throttle is pressed and won't stay running. So I tried to run this yesterday, and I found it was very easy starting, but it was definitely adjusted way too lean. When I checked it with the tach, it was revving up to about 15,000 RPM. And so first thing I did was, I loosened the limiter cap on the high-speed H screw, and I went counterclockwise on the high-speed screw and enriched the mixture, and that slowed the engine down and got it into a point where I was happy, about 13.5. The book says this saw is not supposed to run over 14,000. So, I've got the high adjusted, but when I would come off the throttle, come back down to idle, it would want to idle for about 10 seconds, and then it would lean out and die. And so no matter what I did with the low-speed screw, does not have a limiter cap on it. And I tried lean, rich, lean, right in the middle, back and forth, and I could not get it to have a stable idle. It unless I was very quick on the throttle, at about the 10-second mark, it started to lean out, and if I was too slow throttling it up, it would die and I would have to restart it. So I suspected that the high-speed check nozzle in the carburetor is probably the issue. And that's what this episode's going to be about. This is a lot of mechanics have no idea what a high-speed check nozzle is, where it is, what it does when it's not working properly. They just have sort of a hit and miss approach to their carburetor overhauls. They put a bunch of kits in a few dozen carburetors, and they have 50-60% success rate, and then a very high failure rate. And a lot of times some of those failures are the high-speed check nozzle, and so that's what we're going to address today. The high-speed nozzle on a lot of these carburetors, especially the high-end ones, they're serviceable, but they do not come in the repair kits. Now, a lot of the lower-end product, the high-speed check nozzle is not serviceable if it's a really cheap piece of garden equipment, and you have no choice but to replace the carburetor. And that's somewhat of the case in this saw, because this saw, it's about a 2008 vintage, according to the sticker here, and the carburetor for this one is inexpensive. It's only $40 to $45 for a whole new carburetor. And so it's not a big deal. It's readily available and low in cost. You can just replace the carburetor and cure the problem. So in a way, this is kind of a bad example, but it's very seldom when I run across a piece of equipment that does have a bad check nozzle. And I would have preferred to have like an expensive professional saw that was vintage, and maybe the carburetor was no longer available, or the carburetor is still available but it's extremely expensive. And that would have been a better example of something to repair in this video. But we're going to go with this one because I don't know when the next time I'm going to run into a bad nozzle is going to be. So we'll just pretend that this carburetor is expensive or no longer available, and you have to fix it with what you have. I tried to run this saw today earlier, and the problem is intermittent. It seems to be running better today, but I'm not going to take a chance. I'm going to take this apart and show you where the nozzle is and how to check it and how to replace it, and we'll go forward. First thing that I found is the customer did install a maintenance kit in this. It has a brand new spark plug, brand new fuel filter, and a brand new air filter, and that didn't make any difference at all. The next thing I found is that the tank vent hose comes out of the top of the fuel tank, and it kind of goes around the back of the air box behind the carburetor and goes to a tank vent over here. And I noticed that the hose was back over on this side was compressed, and there was a flat spot in it, and I'm pretty sure it was blocked. And so definitely that is a problem, easy problem to fix. Steel, they only make about 3 different types of tubing, and this one called out for an R3, and R3 tubing is 3.1 millimeter inside diameter, 5.7 millimeter outside diameter, and it's sold in either 1 meter or 10 meter lengths. And then you unroll it and measure what the illustrated parts list says, and you cut it to length, and that's what I did. So I replaced the vent line, and I ran it, didn't make any difference. That was yesterday. So today we're going to go deeper, and the explanation of a high-speed check nozzle, I'm going to be referring to this Walbro service manual, even though this is a Zama carburetor, just because it has pretty good pictograms that are color-coded, so I can use this as a visual aid. So we're going to talk about, the high-speed circuit, the low-speed circuit, the high-speed nozzle, and so on. So it's important to know the color coding. The red represents fuel. The light blue represents air. The yellow represents positive and negative impulses from the impulse line in the bottom of the engine. And if I was doing this drawing, I would have had different shades of blue. Like I would have had a dark blue for atmospheric pressure, a medium blue for moderate vacuum, and then a very light blue for high vacuum, low pressure. So we're just going to pretend that this white area is a light blue, and that this is a medium blue. So in this idle position, this is the position of the throttle shutter and the choke shutter in the idle position. You have your air cleaner out here, and you have your engine out here. And so the air is traveling this way. And you have your high-speed nozzle, which is dormant during idle. Nothing's going on here. The idle circuit is 100% responsible here for delivering fuel when the engine's idling. And part of the idle circuit is exposed to the very low pressure, high vacuum side of the throttle butterfly. And that does create a slight draw vacuum in the metering chamber. And when there's a slight vacuum here, the atmospheric pressure will go through the hole in the metering cover, and the atmospheric pressure will push on the diaphragm. And when this pushes on the diaphragm, it's going to push on the lever, fulcrum lever, and the fulcrum lever pivots and lifts the needle off of the seat. And then this fuel pump side of the carburetor, there's 2 or 3 psi of fuel pressure behind the needle. When the needle's lifted off the seat, that fuel is going to flow into the metering chamber. And then your carburetor circuitry is there to deliver the fuel, and the mixing with the air, the fuel and the air mixing happens in here. So what can happen is this high-speed nozzle, during idle, it's dormant, and there's a check valve right there. And I'm going to explain the different types of check valves that I've run across in a few minutes, but we're going to continue with this explanation. If low pressure air is coming into the carburetor and your very, very low pressure air is on this side of the throttle shutter, the air will be like a crowd of people kind of walking towards the elevator door. And then the elevator door closes and these people kind of pile up and back up. And there's an opportunity for the air, I guess the people is representing the air, they got to go somewhere, so they just go down the high-speed nozzle, and they want to end up in the metering chamber. So you have to have a one-way valve when the high-speed circuit is dormant, and it's supposed to stop air from migrating down through the dormant high-speed circuit and entering the metering chamber and polluting the fuel with air. So if you can imagine, if this valve was bad and this light blue went down the nozzle and got into this area that's red, okay, so there'd be some blue in here instead of red, and then that blue is going to be introduced into the low speed circuit and come up here, and then you have no fuel and the engine leans out and dies. Now on this diagram, this is what's called an independent circuit carburetor. Well, a lot of carburetors have dependent circuits, and the idle does not pick up its fuel from the metering floor. This would be blocked off, and then this would be over here connected to the high-speed circuit and is dependent on the high-speed circuit. And on a dependent circuit carburetor, the air bleeding backwards through a defective check valve can take a shortcut. It doesn't have to pollute the metering chamber. It can just take a shortcut, and air can go directly to the low-speed circuit, and then the engine will lead out and die faster. And so that's what's going on when you have a high-speed nozzle and check valve. It's supposed to prevent air from going backwards during idle. So I might refer back to this in a few minutes. I've seen about 4 or 5 different types of check valves. The very, very earliest high-speed nozzle check valves were nothing more than a screen. And those were common to the Tillotson carburetors in the late 50s and very early 60s. And like on a Tillotson HS, the early ones only had a screen and the high-speed nozzle. And so you're probably wondering, well, how is a screen going to prevent air from going backwards? Well, I did an explanation in one of my other videos. If you want to see that video, that's the Steel Vintage Chainsaw Repair. And that one, I had to break it up into 5 parts because it was pretty long. In part 3, I addressed that issue when I was overhauling that carburetor. And those early type of check valves seal by what's called capillary action. And so if you want more information, you'll have to watch my other video. The next style of check valve, next generation, was like a circuit plate. I think Walbro came up with this one. It had a circuit plate and it had a rubber flapper, like a lay flat valve that's similar to the 2 lay flat valves that are in a fuel pump diaphragm. And that style, I can remember that Echo was well known for the PB400 blower. That was the first really good commercial backpack blower, and it had a WA55, and that carburetor had that style of high-speed check nozzle with the rubber flapper under the circuit plate. Another type of outdated, obsolete check valve I've seen was Steel back in the day when they first came out with the 020, not the 020 Super, but the first 020. They were using the Tillotson HU carburetor. And then when Walbro came on the scene, the WA1A was the very first Walbro carburetor that I guess Walbro ever made, and it ended up on the Steel 020, replacing the Tillotson HU. And that had like a little brass donut with a wafer, a disc wafer, and that carburetor was terrible. I can still remember, tinkering with those, and the 1A was replaced. WA1A was replaced with the 1B, the 1C, and the 1D, and they were all crappy. And then they finally went to a WA86, and that had a little bit more modern style of check valve, and that was a good carburetor. The next type of check valve that came along, was the brass seat that had a screen in it, and then it had a disc, and those were pretty common in the HDC, HDB, and some of the HDAs. All of the HDA, B, and C carburetors are all now obsolete, and Walbro has an HD carburetor, which is current. And the HD uses the newest style. The newest style is like a brass capsule, and the brass capsules either use a nylon ball or a rubber or Teflon disc, and that's what is current and prevalent. Going back to the HDC and HDB style check valves with the brass seat and the screen, a lot of people misconceive the function of the screen. They thought that screen was in there to atomize the fuel. It probably does atomize the fuel, but that's not what was intended. On an HDC carburetor, the actual Teflon or rubber disc settling back down on top of the brass seat is what checked the air from going backwards into the metering chamber. The screen didn't do a lot in those carburetors. Maybe it kept dirt from causing the check valve to stick. Whereas in the first version of the Tillotson HS carburetor, it only had a screen and that's all it had, and that seals through capillary action. So what I'm going to do is I'm going to remove some parts off of this, and we're going to get into the carburetor, and I'm going to show you where that nozzle is and how to service it. So I'm going to try to shorten the video and edit out the nuts and bolts. I'll come back when it's apart. Okay, we're back with the carburetor off of the saw, and just before I open it, we're going to connect our pressure tester and just double check that it is holding pressure. It's supposed to hold about half a bar. If you were to pump it to excessive pressure, if you pump this thing way up, that will damage the pump diaphragm. You do not want to go over a bar. Really, about half a bar is all that's needed. And you can see that it holds. And I've got some of my special tools here ready to go. One of the tools that I like to use, this is something that Echo recommended. Learned this from the Echo service schools. A lot of the Japanese screws have what's called a JIS Phillips, or in Europe they call it a plus. They call a slotted a minus, so plus minus in Europe. In Japan, the JIS is a different taper than the American Phillips number 2. So the way you identify that is there are very, very small dots. If you see those little tiny dots on the head of the screw right next to the slot, that identifies it as a Japanese industrial standard screw, and they fit much, much better than an American Phillips, and you can really get a lot of force on these before they strip. I'm going to take the fuel pump side off. Very, very clean. No dirt issues in there. That's not the problem. And then take the metering side off. Same thing, these screws have a very small dot. A lot of Walbro carburetors have that JIS screw, the newer ones. And this screwdriver fits them better than an American number 2 Phillips. Much better. Okay, and the metering chamber is full of fuel. That's a good sign. And so now we're going to point out the high-speed check nozzle. It's pressed into the metering chamber floor right there. And this is the high-speed jet. The low-speed jet is underneath the metering lever. It's hidden from view. It's just underneath this metering lever. So, and then there's a Welch plug to cover up the low-speed circuit. And the high-speed circuit picks up fuel from this jet and from this hole. And this carburetor has some kind of neat things on it. There is a nylon block right here that runs laterally through the carburetor body, and it makes the high and the low adjustment needles airtight around the threads. And in addition to that feature, this carburetor has an accelerator pump. We'll flip it over here to the throttle side. And underneath this throttle shaft, there is a piston and an O-ring. Maybe you can see the flat. When I turn the throttle, there's a cam. And I don't think that that's an issue. I have had some accelerator pumps go bad. The MS200T steel top-handled arborist saw was famous for these accelerator pumps wearing out and introducing air into the carburetor where it's not supposed to be. And that's because a top-handled arborist saw there's a lot of on and off the throttle, on the throttle, off the throttle, off the throttle, on the throttle, and they wear the accelerator pumps out. On a standard chainsaw, rear-handled chainsaw like an MS250, there isn't a lot of constant action going on here, wearing out the accelerator pump. So, that accelerator pump is sort of hidden right in this area in the carburetor body, and to service it, you would have to remove the butterfly screw in the butterfly and pull the throttle shaft out of the carburetor body, and then the pump piston would come out of that bore, and you could replace the O-ring. But at that point, you'd probably want to replace the carburetor. So just wanted to point that out. That's not the problem with this carburetor. Now, one feature on this carburetor is that this high-speed nozzle is not perpendicular to the carburetor body. It is tilted at an angle, and that is going to make it harder to remove it. The carburetor is going to have to go under the arbor press, and it's going to have to be tilted, and then I can press straight. And that nozzle, you can see it in there. It protrudes. It protrudes into the venturi. You can see the end of it there. And there's enough room in the venturi to press the nozzle through the body and remove it out of the carburetor bore. And what we're looking at, I've got a new one. This is a brand new 1123 nozzle. And we're going to be pressing this nozzle into the carburetor after we remove the old one. And what we can do is we can test. I'm going to get an adapter here. Get an adapter and okay, so I have I pressed the brand new nozzle into a hose, and then I can adapt to my pressure tester, and this way you can bench test the nozzle. And you see the brand new nozzle is holding. Okay, so we got a good nozzle here. So the next step is to remove the old nozzle. And I've got a drill press vise that is a tilting, it's an angle vise, and I can close the choke and put the carburetor in here. let's set this up on the arbor press. And just find a piece of metal, anything that is smaller in diameter. It's got to be smaller in diameter than the new nozzle. It's got to pass through the bore in the carburetor. And I'm going to need my magnifier here. I need my magnifier. I'll be right back. Okay, I've got my magnifier and I'm lined up better so I can press. Okay, so that went all the way through. And now we can retrieve the old nozzle from inside the venturi. There. Okay, and then what we can do is pressure test the old one. And we got ourselves a leaker. So we're going to press the brand new one in. I don't want to overpress it. Right there. Okay, so our new nozzle is pressed in and we're ready to reassemble. All right, back the camera up. Okay, so I always rebuild wet, and the explanation for that is also in my steel vintage chainsaw repair 5-part episode, And if you want to see, that part, the fuel pump, that is part 2. And then you'll understand why I rebuild wet. So we have a new GND 35. I like to get these when I can because the steel equivalent is $20 and this is only about $6. And they're exactly the same parts. Steel was Zama's largest customer, and they ended up buying more and more of their stock and acquired 50 or 51%, the majority of the company. And then at that point they cut off all of the aftermarket Zama repair kits for steel, and forced everyone to buy the Zama kits from Steel under a Steel part number, and they're much more expensive, kind of a ripoff. So you definitely want to add fuel, and you have a choice of pump diaphragms. We're going to be using this Mylar one because that's what came out of the carburetor. These old rubber ones are for the earlier carburetors that the body was not machined. There was like a rougher casting, and that required the rubber pump diaphragm. This one is machined, and what came out of it was the Mylar. This is what was in there. That's what I'm going to put back in. Like when the gaskets just cleanly come off. And important on these pump covers, surrounding all of the chambers on the pump cover are what are called crush ribs. And those crush ribs, they bite into the gasket and make the gasket seal. Air and fuel cannot move laterally through the gasket material once the pump cover is tightened down securely. Those crush ribs bite into the gasket and seal it. If you end up using like a poor aftermarket quality repair kit, those gaskets are pretty leaky. They will not seal like the genuine OEM Zama or Steel gaskets. Got to open the throttle a little bit to get that pump cover in there. And this is where your Japanese industrial standard number 2 Phillips will precisely fit the pump cover screw, and you want this tight. If you tighten this up girly tight, it's going to leak around the pump cover. And we can just put the pressure tester on there to verify. And it's 100% holding, over half a bar. Now, as far as metering lever height goes, I had previously adjusted this. It was a little bit low, and that's one thing. The Zama metering lever gauge is a little bit confusing. um, all of the imprinting is vertical here, and that sort of fools you into thinking, well, all these carburetor models are to be using this side of the Z gauge with this extension. Well, that's not true. This is a C1Q, and you're supposed to flip this gauge upside down and use it directly on the gasket surface, not the floor of the metering chamber, the gasket surface that's raised above the metering chamber floor. And what they want is the metering lever to just barely touch a straight edge or the Zama Z gauge. And an extremely accurate way of setting the metering lever is, like, if you have not very good eyes and you need, really good magnifying glasses, you can use the pressure gauge. You can apply some pressure to your gauge, and you can, raise and lower the metering lever until you get just the tiniest amount of leak when the gauge goes over the metering lever. And you saw it just barely move, just barely. See, the needle is now going down very, very slowly. That means that this lever is just microns higher than the surface of the carburetor body. And that's a little more accurate than just trying to do it by eye and getting a light drag on the metering lever. That is the accurate way to adjust metering lever height. I like to use the gauge and do it that way. And then once again, I rebuild wet. The gaskets and the diaphragms always seal better when they're wet. And this is nothing but 2-cycle fuel. That's all it is. And you always want to check the diaphragms. Sometimes rough handling, the umbrella frame will get bent if it's been damaged in shipping. I check these before I put them in. This one is flat as a pancake. That's what I want. Okay, and then once again, I'm using my JIS number 2 Japanese Phillips. It's made to fit these screws. These screws also have a very small pair of dots next to the slot that identify it as using this screwdriver. These do not have to be as tight as the pump cover. The metering side is not as critical as the pump side for leaks. Pump side, no leaks. And so that is a rebuilt carburetor with a high-speed check nozzle replacement. And videos are often too long, so I'm not going to do the nuts and bolts and put it back on and put the gas in the saw and start it and run it, and I'm going to cut that part out, but I'm assure you that it will work. And this series, Carburetors 101, this particular episode is more like Carburetors PhD. This is pretty deep, but it is important to know. And when you've got crappy mechanics that work for you, like I had Secret Agent Man, and The Big Asset, and Scratch. And Scratch supposedly had 40 years experience, but it just didn't show. And then we had Gomer and Dingus and our newest mechanic, Speedy. His carburetor overhauls are terrible. And, these guys, this is way over their head. I don't even know if they would absorb this and retain it. But there are going to be carburation, small engine carburation in more than just chainsaws. We're talking, 4-cycle lawn and garden and all of the handheld 2-cycle stuff and the hybrid 4 mix, hybrid 4-stroke. There is so much information. There is no way I could cover this in one video. There's going to be dozens and dozens and dozens of Carburetor 101 videos coming. There's just way too much to pack into one video. So I hope you learned something from this, and we'll pick a different kind of machine next time. It's going to be a different one every time. They're not all the same. So it's the Unknown Mechanic signing off. We'll catch you on the next one.